Hello, Kurgan cousins. How are you today? I was thinking about the other day when I taught you in third grade, and I used to always call you the Kurgan cousins. And so that's why I just called you that, is because it reminded me of that. So in your packet today, you have a weather map, and I want you to pay attention to the H's and the L's. That's, of course, the high pressure and the low pressure in the map. And I want you to answer the questions based on what we've learned about air pressure. And so number one says, looking at the map, do you see high pressure or low pressure on the East Coast? So this is the East Coast. So you should write H for high pressure because there's high pressure on the East Coast. Then it said, name the states that are in the low pressure zone. So that could be here, here, and this area. So there's several. Oh, we skipped a part of number one. I'll go back in just a second. So it looks like Oregon, Washington, Idaho. Oh, that A on Washington, that looked good. Idaho, California, Arizona, Colorado, and New Mexico. Those all have low pressure zones. A lot of the low pressure zones are on the borders. So that's why there's so many states that it's affecting. And then it says, the second part of number one was when we was talking about the East Coast over here. And it said, what will the weather be like if there's high pressure? So if there's high pressure, that usually means that it's calm weather. So there's not a lot of wind. It's usually nice and sunny. It can be cloudy and overcast, but still be really calm. Not a lot of weather pattern. But typically high pressure is sunny. So, you'll see high temperatures on high pressure a lot similarly. Then it says, do you see anywhere that high pressure zone is relative to the low pressure zone, relatively near the low pressure zone? So we see that right here. It's kind of on the border of Idaho and Washington and Oregon. And it said, how would that affect the wind in that area? Well, what happens is when those zones get together, that high pressure and low pressure zones get together, that high pressure is trying to get to the low pressure. It's something that it's always trying to do. The high pressure is always trying to get to the low pressure, and that's what creates winds. So it says, do you see anywhere? Yes, we see it in Washington, Oregon, Idaho border, and it's going to be really windy. So whenever we see that high and low pressure together, it's going to be really windy. So what do you think it might mean when there's neither high or low pressure? So like in this area right here, oh, sorry. My gosh, in this area right here where there's not a lot of high or low pressure, it's just going to be really calm. It's not going to be super sunny or windy. It's, when there's not a lot of pressure, it's just things are really calm. There's not a change. So on number 4, we'd write really calm. In fact, I think number 1, a better choice than calm. Calm is really when there's not a lot of pressure, but when there's high pressure, it's usually sunny and it's usually warm. So that's probably a better answer for number 1, because calm is more when there's no air pressure change at all. So when you see the high pressure fronts and the low pressure fronts in weather, it's indicating that there's something that's going to happen in the weather to change it. It's the number 1 indicator of weather changes. Meteorologists, they measure temperature and they measure air pressure and they measure the amount of wind. They measure precipitation. But the number 1 factor that weather will change in some way, whether it will get better or worse, is the air pressure. And so that's something that they really look at closely, is that air pressure. Okay, so now that we've talked about the weather map, if you need more time to write this down, go ahead and hit pause and you can finish writing it down. Otherwise, we're going to go on. Okay, so the next thing that I want to talk about is this true false quiz. So, I think I had you, I'm trying to remember, but I had the sixth graders in class fill this out before we started learning about high pressure. And then today I'm actually going to have them use a different color pencil or marker to fill it out again to see what they learned. So if you can get that true false out, I will look and see. I didn't get a chance to grade your papers yet, but if it's in your papers, I'll look for it and return it to you. But with a different color marker or pen, I want you to write on this quiz again if it was true or false. It's not really a quiz, it's more of just like an activity. You just get points for doing it. It's not really you don't lose points for it. I just want you to notice the differences in what you thought before you learned about air pressure and what you think now. So go ahead and hit pause and complete this again with a different color pen. Okay, let's look at this true false quiz a little bit closer and we'll go through the answers together. So it says cold air exerts more pressure than warm air. That's actually false. High pressure is warmer air and low pressure is usually colder air. So in Eureka, we are higher up and we tend to have lower pressure and colder temperatures. And then as you go down in the valley, they have warmer temperatures and they have higher air pressure. So it's all kind of related together. The way that one video that we watched in class kind of described it was, if you picture a big, huge stack of eggs, every egg that you pile onto the next egg is going to create more pressure of coming down. So if you're in a lower area, you're going to have more eggs to get to the same place as if you're in a higher area like a mountain range. So the higher area is obviously going to have less air pressure than the lower area. So you're going to have high air pressure in low altitudes. It's going to be nicer and sunnier. And then in high altitude, you'll have warmer air pressure. So that first one is false. There would be more air pressure if you were on top of a mountain. That one's also false for that same reason. As the amount of moisture in air increases, the air pressure decreases. Let me think about that one. As the amount of moisture in the air increases, the air pressure decreases. So that's like humidity. So I think the higher you are, the less humid it is. So the amount of moisture I think that's false also, because the amount of moisture increases at like sea level, but the air pressure is higher at sea level, so it would make sense that that's false. A high pressure system usually brings snow or rain or wind. No, that's false, because high pressure is nice days. Low pressure system brings cooler and drier weather. Well, low pressure actually brings cooler, but not necessarily dry weather. It could be dry or wet, so that one's false too. We're getting lots of falses today. In high pressure, the molecules are close together and dense. Yes, that is true, because you have to picture things being piled on top of each other. And so those molecules being piled on top of each other become more dense. They kind of get squished. So that one's true. Warm air is less dense than cold air. That one's false. Warm air is actually more dense. As the temperature increases, the air pressure increases. That's true. As altitude decreases, air pressure decreases. That's false, because if you go up higher, you have less air pressure, not if you go down. The weather map symbol for high pressure is a lowercase h. That's false. It's actually an uppercase H. air does not have mass. That's false. Air is actually a thing. We can't see it, we can't feel it, but it's there, and you can trap it. From our experiments that we did, you know that air is a thing. If you don't have air in a place, you wouldn't be able to trap it. So even like a balloon, if you think of blowing up a balloon, there's something in the balloon that's stretching that balloon out. So it's a thing. It's hard to see and feel, but it's there. And so we know that it has mass because it's actually a thing. Air pressure does not crush us because air pressure pushes in all directions. That's true. Rising air pressure means weather is clearing. That's true. When air gets warmer, the pressure goes down. That's false. When air gets warmer, the air pressure actually goes up. So, how did you do? Did you change some of your answers from when you first did it? Go ahead and hit pause if you need longer to check your work. When you're done, hit play again. Okay, so now we are going to go on to these slideshow notes. I want you to fill these out as you go. I'm going to go through this slideshow. I'm not going to fill it out for you today. I want you to do it on your own. I want you to listen to the slideshow carefully and fill out the sheet as you go. And then I'll look at it when you turn it. Oh, sorry. I'm yawning. So I'm going to go through this slideshow and I want you to fill out the notes. I only am able to record about 4 more minutes on this video, so I may have to stop it before I'm done with the slideshow and start a new video. So you'll know that there was 2 videos when you watch this first one. And so if I stop it, we'll just pick up where I left off. Okay, so today we are going to talk about air masses, weather fronts, and air movement. Air mass is a large unit of air which has the same properties, temperature and moisture, as the area over which it's formed. So temperature and moisture conditions determined by a source region of air mass. So there is some abbreviations that they use when they're describing where it's at and how much precipitation, which is moisture, humidity, and what the temperature is. So depending on the area of the land, the air is going to have some of those same properties. So this is the source region. So it shows that continental and maritime is the kind of moisture that CM has. So let's see. Oh my goodness. ICCT. So T is tropical and C is continental. So these CTs right here in the middle are tropical continental, which means they have like tropical climate, but it's not an island. It is a continent. And then Arctic is AA. So this is a continent with Arctic climate. MP is maritime. So there's a lot of moisture because it's above water there, and it's polar, so it's really cold water. So it's continental is like inside on land. Maritime is ocean, and so if it's continental like Africa here, this is where Africa is. It's going to be continental, but then the temperature is tropical weather, so it's continental tropical. It's maritime if it's the ocean. So this one here is going to be maritime equatorial, which the temperatures really are high in equatorial regions. And so it's maritime equatorial because it's the ocean and that really nice weather. Okay, my video is going to make me stop recording here in just a second, so I'll pick up with a new video on this slide in just a minute. So go ahead and start the next video.